Particle size analysis by sieving is a method of separating and classifying granular material that dates back to ancient times. Today, sieve analysis, used by material scientists and engineers, determine particle size distribution for many materials to accurately meet quality control requirements. Hand sieving is the most basic way to perform sieve analysis and is acceptable for applications where a high degree of efficiency, accuracy, and repeatability are not essential. Results are highly operator dependent and can vary significantly. Using a sieve shaker automates the agitation process for particle separation and size determinations. Let's compare hand sieving versus using a sieving device. In using the hand sieving method, you first select a single test sieve with an opening required by the test method specifications, such as a Gilson 8-inch ASTM E11 stainless steel compliance grade test sieve. Place the sieve onto a sieve pan. Now place the clean, dry test sample onto the sieve. While holding the sieve and pan together with both hands, sieve the material with a gentle circular motion and using your hand to repetitively tap the side of the sieve to promote passage of near-sized particles through the sieve mesh. Continue sieving until no more than 1% by weight of material passes through the sieve during 1 minute of sieving action. Now, remove and weigh the material remaining on the sieve to calculate the percentage of the bulk sample. Using a sieve shaker saves on testing time, automates particle agitation, and improves accuracy and repeatability. There are 3 main types of sieve shakers: mechanical, vibratory, and sonic. Choosing the right sieve shaker will have a significant effect on your test results. Particles react differently to different mechanical actions. It is also important to consider these other factors when sieving. With all these factors to consider, how do you know which sieve shaker is most suitable for your purposes? Let's take a closer look at the different shaker types. Mechanical sieve shakers have a motor-driven mechanism to agitate and reorient particles with orbital, circular, or rotational motions. And some mechanical shakers also use repetitive tapping to the sieve stack to enhance passage of particles and prevent the blinding of mesh openings by near-sized sample particles. Mechanical sieve shakers are often the more affordable choice and may be sufficient for free-flowing materials that are coarser than number 200. For example, the Gilson SS14 and SS15 orbital sieve shakers, which feature a back-and-forth lateral motion combined with an up and down and tilting actions that moves the test specimens in an orbital direction on the sieve cloth. Or consider the Gilson SS8 and SS12 tapping sieve shakers, which have a research-based sieving action that produces sharp, repeatable separations quickly over a broad range of particle sizes and material types. These shakers have a superior circular rotation that prevents dead spots on the sieve mesh, plus a 2-way tapping action to mix, reorient, and redistribute near-sized particles to clear the mesh openings. Vibratory sieve shakers are ideal for powders and many granular materials, including minerals, pharmaceuticals, metals, and cosmetics. By using electromagnetic energy to evenly distribute test samples and encourage fines to pass through the mesh. For example, the Gilson SS10 one-touch vibratory shaker, which combines the latest in electronic control with proven separation technology to ensure the maximum number of passing opportunities without the loud noise of mechanically operated shakers. The SS10's three-dimensional vibratory action with its programmable test cycle pause function and amplitude control creates a fluid bed which evenly distributes the test sample across the sieve mesh as it continuously lifts and reorients particles. Or consider the SS3 vibratory sieve shaker with its amplitude control and inline solenoid actuated tapping action to redistribute the sample on the sieve cloth and clear undersized particles from the mesh openings. Sonic sieve shakers, or sometimes called sonic sifters, use acoustic energy to create an oscillating column of air for agitation, and vertical and/or horizontal tapping assists in separation. Rapid pulses airlift each particle off the sieve cloth, causing it to reorient and land on a different opening to assist in particle separations. For example, the Gilson GA6 Auto Siever Sonic Sifter and the GA8 Ultra Siever Sonic Sifter uses continual agitation of 3600 sonic pulses per minute with a vertical oscillating air column and with mechanical tapping that lifts, reorients particles. So, as we can see, using a Gilson sieve shaker is the only choice where a high degree of efficiency, accuracy, and repeatability are essential. For any questions about which Gilson sieve shaker is right for your material testing lab, or for any Gilson product, please contact your Gilson technical support team.